Good evening, everyone. My name is Charlotte Stamper and I am Strategic Partnerships Manager at European Metal Recycling. We're the world's biggest metal recycling company, and my day job, I take apart wind turbines. So I was really delighted to be asked to contribute to this report. Now, the crux of the report is talking about demand reduction. And renewables and clean tech are completely reliant on critical raw materials. So actually, for me, demand reduction and renewables, they actually sit as quite uneasy bedfellows. And I just wanted to really address that to start with. Decarbonisation is not optional. We have to do it. As Joan said, we're on the way, but we have to do it bigger, quicker than we are at the moment. We have no choice if we want to really limit to whatever extent we can the irreversible climate change, the path that we set. But having said that, there are many different ways to meet net zero, and some, coming from the renewables background, it's actually very rare. And Lorna, who's sitting in the room, also works on this topic as with me. It's almost never mentioned when you're at a renewables conference, this idea that renewables infrastructure doesn't just materialise out of thin air. Like everything else, it has to be made, it has an impact, and we have choices about how we do that. And given that renewables are going to be an absolutely fundamental and critical part of the transition to this brave new world that we're on, I think it's absolutely right and actually long overdue that we're asking questions about how we do this. And that, like Joan said, there's some very real choices we need to make now. And I think we should be absolutely leading from the front in the UK on how we do that as well. So just wanted to spend a few minutes talking about offshore wind in particular as a case study from the report. So I love wind turbines, but I'm going to try and keep this very succinct, otherwise we'd be here all evening. Offshore wind is a fabulous technology. It will be a cornerstone of the global push to net zero. And offshore wind turbines are huge. If you've seen ones on land, you ain't seen nothing, because the offshore ones are as big as the Eiffel Tower. I love this picture that I've put on the left. So those are 10 megawatt turbines that last year got bought through a place called Broughty Ferry, which is near Dundee in Scotland, and they're going out to sit about 15 kilometres off the east coast of Scotland. And the yellow bits are just the bit that sit under the water. So the structure that goes on top of that is some 200 metres tall. And those are small ones, actually. Those are 10 megawatt turbines. We now have 15 megawatt turbines on the Murray West wind farm, and the Chinese OEM Mingyang is developing a 22 megawatt offshore wind turbine. Of course, all of this needs materials to be made. Lots of steel, lots of concrete, lots of copper to connect them to our grid. But actually the thing about offshore turbines, in contrast to their smaller onshore cousins, is that in order to convert these massive rotational forces into electricity, we use things called permanent magnets. Now these contain a large amount of critical raw material called neodymium. And we need a lot of neodymium to make all of these turbines turn. So we really need to plan now for how we're going to recover this material at the end of its life, and actually think about the fact that we're locking in that demand for the future. As Joan said, the decisions we're making now will last many decades into the future. So this is how we looked at it in the report. First thing is to think about infrastructure and technology planning, and it had a UK lens. Now, the UK, we're an island, and we're a really windy one. UK actually has more offshore wind resource that we can exploit for offshore wind than all of the next 5 European countries combined. So it does make sense that offshore wind will be a fundamental part of how we reach net zero and decarbonise everything in the UK. And we're aiming for 50 gig of offshore wind deployed by the end of this decade. And actually we're on track to have over 100 gig by 2050, which is some, depending on the size of them, 8,000 to 12,000 offshore wind turbines. And there's a move towards floating turbines, which will allow us to access deeper water, higher wind speeds. And indeed, offshore wind will be the biggest contributor to the GB electricity generation by 2050. But we have choices about how much energy we need. What mix of turbines do we put where? Some of them have bigger material impacts than others. Some need more concrete, some need more steel. All of them need neodymium at the moment, and we're not thinking about this. Believe me, as someone who comes from the renewables world, there is zero consideration of this. It's very easy to stick another 0 on a deployment target and not realise how that translates into tons of real things. So we're urging for this to be a huge upfront consideration when we're making these choices. Yeah, as I said, that's the size of one of these. There's a 12 megawatt nacelle. Those turbines are being made and deployed the world over at the moment, and that's just the bit that the blades attach onto where these massive magnets go. There's almost no consideration of end-of-life materials in the planning. And furthermore, if we're buying all of this resource into the UK, putting my UK head on for a second, isn't that a massive strategic resource that we're going to have into the future? We actually have our own urban mine of critical raw materials that we're bringing in by the shed load. So if we're deploying all of this offshore wind, we should start considering it as a material bank as well as a way to make electricity. This is a few pictures from my day job and trying to think about how do we design better to try and mitigate some of these issues. So we're trying to take apart the first wind turbines that were ever made about 30 years ago, coming to the end of life, very small onshore models. So the picture on the top right, that's actually some of my team trying to take apart a demonstrator scale, absolutely tiny, offshore wind stator that's jam-packed full of these permanent magnets. It's quite hard to do, actually. But there are some really consistent challenges coming through as we're taking apart these early models that I think we need to learn the lessons of for the future ones and design better. So there's no record of design or component composition. We're very lucky if we get any information about early turbines when they come in, let alone things like materials passport. No consistent standards, especially in the early models, and they were all made for low cost, and that is true today because the biggest single pressure on renewables developers is cost. So these problems have not gone away. In actual fact, they've got a lot worse in some cases. And the picture on the bottom left-hand side is to show some of the sort of differences in choices in a very practical way. So we've seen magnets that have been bolted in, and that's the right-hand side. So that allows for easy removal, repair, recycling. We love that design. But unfortunately, most of them are like the picture on the left-hand side, which is just whack it in with a load of epoxy glue because that's cheap and easy. How do you get that out at the end of life? The carbon contaminates the neodymium in the magnets, and it's just a complete nightmare, and it actually results in huge material loss. So that was just a practical example I wanted to show. Everything is cost-driven, but it's the upfront cost, it's not the long-term cost. So we have to design new assets with the end in mind, particularly with reducing demand for CRMs and then recovering them better. So the final thing we look at is circularity. Most wind turbines have a design life of 25 to 30 years. We've already started deploying offshore wind in the UK, so by the end of almost 2040, 1,000 offshore wind turbines a year are coming to their end of life decisions. We currently have no plan for how we effectively cover these materials. In order to do that, we'll need ports, we'll need vessels, we'll need skilled people. Again, believe me when I say no one is planning for this. Everyone is planning for this for the build out of turbines. We're not thinking about how to get them back. And like I said, because they have critical raw materials in, they've effectively become a strategic resource for the UK and something that we'll need to think about long into the future. So the final slide, Isabella and Kane just asked me to present two different futures for what offshore wind could look like in the UK. The red crosses, no surprise, that's how it's going at the moment. So disregard for material demand in net zero planning. We're reliant on imports, we buy everything. We don't really recover materials very well. High raw material extraction and environmental impact. And this is a key one for me. We're so vulnerable to supply disruption. People think that renewables projects won't happen because they won't get planning or they won't get their grid connection. And I keep saying to them, what happens if you can't buy your turbine? What happens if we can't make enough? What happens if China says, sorry, you can't buy them from us? These are real prospects. We live in an uncertain world. It's not being planned for. So where we want to get to is with the green ticks. First of all, we only build what we need. That makes me really unpopular at renewables conferences, but I am passionate about that. We do not need to deploy more infrastructure if we can get our energy systems right. We need efficient materials recovery and recirculation. This isn't a one-time thing. Renewables are here for a long, long time, so we need to get better at having that closed loop plateau of demand. It would give us price stability. We would no longer completely exposed to huge fluctuations in critical raw material price, and it would guard the UK against the global shocks that I mentioned. So there are many different angles where the take-up of the recommendations we put in the report would actually help us towards what I think would be a better net zero than what we're currently headed for. So I'll stop there. Very happy to take questions on the panel with everyone else, and thanks.